Hey everyone, I wanted to make a video about computer vision for blueberries, which is what I worked on for my PhD. So I'll share a little bit about my PhD work and also some newer work I've been doing with VLMs, or vision language models. So to start from the very beginning of this research project, I did my PhD at NC State, and our Blueberry collaborator is Jessica Spencer. And as a part of their research protocol, they take these images of these blueberries in a very repeatable way with a mobile phone or mobile device. So we're always getting images that look like this in this type of environment. So you get the yellow bin, the blueberries, the color checker pattern. Eventually we'll use this to standardize all images into the same color scheme so that we can compare color. And then we have experimental data linking this image to an experiment. So because these images are taken in a very repeatable way, we can approach it using computer vision. And the ultimate aim of a computer vision app would be to count the berries, to measure them, to find the anomalies. You have green blueberries here, immature blueberries, damaged blueberries, other anomalies. And to connect all of that, all of those measurements, to connect that back to the breeding practices, the genetics. We call this phenomics, right? To go from the genetics to the phenotyping, the physical traits, and then back, so that we can develop tastier blueberries. So the first natural approach that we can take in terms of computer vision is object detection, or simply detecting the blueberries. So initially we labeled a small data set in RoboFlow and used AI-assisted labeling to get up to 300 labeled images. So what you're seeing here is me training a Detectron-2 model to predict blueberry. We did label several classes like mature blueberry, immature, damaged, but this is just mapping all of that to one blueberry class. So the first natural approach in a computer vision project is detecting the blueberries first, right? That's the first step. And then another problem I worked on for my PhD was unsupervised detection of these stem tears, which is when the blueberry gets ripped off and some of the skin gets ripped off, and then you get this stem tear and it's not good, it introduces disease and whatnot. So what I did was I trained a VAE model only trained on mature blueberries so that it only knows mature blueberries, so that when you pass it this anomalous blueberry, on the other side of the neural network, you actually get the difference, and then we can measure this stem tear. And the reason why we're doing it unsupervised is because there's a very small sample of these stem tear classes in the total data set, right? So it's a very high level. You can read more about it in my dissertation, but hopefully that gives you an idea of what I worked on for my PhD. So more recently, I've been experimenting with vision language models, or VLMs, and I've been using this one, Orion, from VLM Run. And the unique thing about Orion is that it has tool calling. And what that allows is for more deterministic outputs. And I'll show you later with the other frontier models that the outputs are more probabilistic or more random. But the benefit of tool calling is that we get these more deterministic outputs. So we call detection, or we call segmentation. So you can chat with Orion. I asked Orion to segment the blueberries. I know in my previous slide I shared object detection, but we can also use segmentation. We can get the masks. Even for my PhD, I also use segmentation, and you can measure the diameter of these blueberries. So using this information, we can create a distribution of small and large blueberries and do a lot of interesting downstream tasks. We can ask Orion simply via chat to find the color checker pattern, and also to find the red tag, which it does a good job of. And as a part of my PhD, I didn't fully get to complete the part with the color checker and this metadata, but it's interesting that Orion can do it out of the box, right? So, and then we can get the JSON here, and that's the important part that we can act on, right? And I wanted to show that. I wanted to show this in comparison to the other frontier models that we can go from segmentation to color checker pattern detection to JSON tag in a few chats, and you can try this for yourself. But just to give some context of what this is ChatGPT, what the other frontier models do. As I've been experimenting in this past week, you notice that these frontier models do image generation. So even this number. They do Gen AI on these images to detect the blueberries. So even this number changes, which is very interesting. even if you ask ChatGPT, can you find the color checker? It literally displaced the color checker because it's running Gen AI on these images. And then I think you can see it again with this tag too. So the number changes too. So then if the number got Gen AI'd, then the number changes. So that's ChatGPT. Gemini ran a key point detection. Gemini is also doing Gen AI. Even I noticed that this is called Calibrite, and Gemini changed the name there too. But it detects, and we can read the text too as JSON. So that's interesting. The Gen AI piece is a fascinating clue into how these models work. Claude 2 is running some more classical computer vision algorithms to find the blueberries. It has a big bounding bugs, and then it also found the tag. So it's interesting how these models behave differently. VLM Run actually did a showdown. So if you go to chat.vlm.run.showdown, you can see all of these comparisons of how they perform differently on all these different tasks. And because Orion is doing the tool calling, you see how visually the frontier models behave quite differently. One interesting one about the Gen AI that I mentioned is in this image of seagulls, you can use a slider to see the difference between Orion and Gemini. And the one I wanted to focus on was Gemini renders a seagull that doesn't exist. So it just shows that they are doing Gen AI. It's really interesting. So yeah, I just wanted to share a little bit about my Blueberry work and what I've been experimenting with vision language models. I think the takeaway is that I did my PhD doing the traditional and classical computer vision approach of training, collecting training data, training the models, evaluating the models. But now we live in this new world where we can chat with these VLMs. Now we live in this world where we can chat with these VLMs to segment these blueberries, to get the masks, to extract the color checker, to extract the JSON of this tag. So it's a very interesting world that we live in now with VLMs, that now we can chat with these models, and eventually we'll get to fully visual AI agents to do these tasks. And even something like the chat interface, it opens up computer vision to a lot more people than just computer vision engineers. So it's interesting to think about. So let me know what you think about this Blueberry project. I'll share the links in the description, and just happy to hear what you think about this project.